9.5, the ambiguous case. Given two sides and a non-included angle, how do you calculate the possible lengths of the third side? And I'm going to refresh your memory with a short video from geometry. When we talked about congruent triangles, there were certain bits of information, so it usually took 3 bits of information to determine whether two triangles were congruent. So that would be like if 3 corresponding sides were congruent of each triangle, then we knew that they were congruent triangles. Or if you had a side, an included angle, and another side congruent to the other triangle side, angle, and side, then you knew that you had congruent triangles. And there was one case where we could never prove congruent triangles, and that was the angle side, or where you had 2 sides and a non-included angle. And I'm going to let this video remind you of that. So these are the situations where we can prove that 2 triangles are congruent. Again, a side, an included angle, and a side corresponding in both triangles. We can prove that we have congruent triangles. Angle, angle, side, 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 and angle, side, angle. Okay, but we could not do it when we had just 3 angles. That was enough to prove that 2 triangles were similar, but not necessarily congruent. And definitely when we had ass or ass backwards, angle, side, side.
Prove that 2 triangles are congruent. And one of these situations is the angle, side, side situation. In other words, a situation where you know that 2 sides are congruent, and you know that an angle is congruent, but it just so happens to not be the included angle. So let's explore this situation. Here I have a side of 5. I also have an angle measure of 32 degrees. And I'm going to construct a ray that represents all possible side lengths for this other side of the triangle. Because in this case, the other side length that we know is actually going to be this guy over here. So again, this situation involves 2 sides that we know, and we know this angle, but it's not the included angle. The included angle would be this angle in between these 2 sides. If we knew that, we would have side angle side, and it would be enough information. But we don't know that angle. We know one of the other angles of the triangle. So the question is, how many distinct triangles can we form with this information? If there's only one distinct triangle, then this is enough information to prove that 2 triangles are congruent. However, if we can form 2 different triangles, then it's not enough information. So let's move this side over here and form our first triangle. So as you can see, we can form a triangle with this information, so that's good. But the question is, can we form 2? So let's create a circle that represents all possible positions of this endpoint C. And you can see that it intersects our ray twice. And what that means is that I actually have 2 different triangles that I could form with the same set of information. So let's go ahead and form these triangles. Triangle 1 and triangle 2. And clearly, we could get out our protractor and our measuring device for measuring length, and we could figure out if they were really different. But as you can see visually, they are. They are 2 different triangles, which means that this is not enough information to prove that 2 triangles are congruent. A common
And what it means for us now is that we potentially have, anytime we are just given an angle and 2 sides where the angle is not included in the 2 sides, it means that we may have 0 triangles, 1 triangle, or 2 triangles, as you saw in the video. Okay, so that was a nice reminder of the ass case. And now we're going to go ahead and do apply this to using the law of sines and the law of cosines. Okay, so let's say, for example, I have a 26-degree angle. And I know that this side is 80, we'll call it centimeters. And this side over here is 50 centimeters. What I could potentially have here is two different triangles, okay? And one of them is going to be where this angle here is obtuse. And the other one is going to be where this angle here is acute. So I have two possible triangles with these measurements, and I'm going to show you how I know that. So we know that SSA or ASS is the ambiguous case, because what that means is that I potentially have one triangle, which would be awesome, but I could have two triangles or I could have no triangles. So in example 1, we're going to take this a little bit further. We have triangle XYZ. X is equal to 50 centimeters. Z is equal to 80 centimeters. X is equal to, angle X is equal to 26 degrees. We're going to find the possible side lengths or lengths of side Y. And in doing this, really what I'm going to do is solve the triangle for you, because I want to show you from the very beginning how I would even approach this in every possible way. So I'm going to do example 1 one way, and then I'm going to show you the way that your book does it. Okay? And the way that your book does it is actually a better way to go, but I want you to be exposed to all ways. All right, so I have basically these triangles that I have up here. Okay, these are the ones that I'm going to work with. This was only the information that was given to me, though. So I have to be a little bit, if you're just given this information with no pictures, you have to ask yourself, what kind of information are you given? And I should say to myself right away, and I would probably draw a picture first, but I have two sides and an angle. Let's make sure that this isn't the ass case, or the ass backwards case. So I know angle X is 26 degrees. I know that this side here is 80 centimeters, which was side Z. And I know that my other side is going to be 50 centimeters. Now the first thing I do is I ask myself, is this side even long enough? Okay, so I know that the shortest possible distance from a point to a line is the perpendicular line, or the perpendicular distance. So if I draw out this triangle, oh, and what I should do is label my angles. This will be side Y. This will be angle Z. And this is side X. First thing I do is I say, all right, let me see what the shortest possible distance is for this third leg, okay? I'll say this is my longest leg. Let me figure out, is 50 even a long enough leg? Okay, so my shortest possible distance from Y down to side Y would be the perpendicular, or the height, right? I'll call that H. Now I can figure out what H is, okay? So I can say to myself, well, H, or I should actually say, sine of 26 is equal to my opposite. See how I have this right triangle here that I've created? So it's going to be my opposite over my hypotenuse. Okay, and then solving for H. H is 35 centimeters. So my shortest other leg that I can have in this triangle is 35, and 50 is longer than that, so I do know that I am going to have a triangle. Because let's say, for example, 50 let's say I had some number like, I don't know, 20 here. Okay, then this side would be too short to even make a triangle. Again, the shortest third side that I could have is going to be 35. And if I have 35 centimeters as a side, then I have a right triangle. Okay, here I've got 50, so I know that I definitely have one triangle can be formed. Okay, so how can I do this? Let's go over, I gave you a handout. Let's look at that real quick. Okay, so I really like this table. It helps a lot, I feel. So first of all, the angle that you were given is obtuse. Okay, well, that's not true. The angle I was given here is 26 degrees. But let's say, for example, that this angle was more than 90 degrees. Okay, then I was given one side, B, and then the other side, so this one was 80, and then this one was 50. Well, if this was an obtuse angle and 50 was less than B, which in this case it is, I would not have a triangle. Okay, so that would be if the angle we were given is obtuse. Or if A was greater than B, okay, so if this side here, like our 50, was greater than our 80, then I'd have one triangle. Okay, that's an easy one to work with. Anytime you're given an obtuse angle, that's pretty straightforward. The problem becomes when you're given an acute angle. Now, the way that they write this is a little bit tricky, but basically what I've done is I've said to myself, let me go ahead and draw in this perpendicular height, okay, which is going to be my shortest leg, okay? And if this leg is bigger than the other leg, my 50 here, then I don't have a triangle, right? Because this side would be too short, okay? However, if this height and this height, they're doing B sine A, okay, is equal, so this is like my 35 side. If that was equal to the side that I was given initially, like my 50 degree or my 50 centimeter side, then I know that I would have one triangle, and it would have to be a right triangle. Okay, that's not our case here. Our case is that we were given 50 centimeters. Okay, so here's our side that was 35 centimeters. That was our height. Okay, which was less than our side that we were also given, which was our 50. Okay, so this was our 35, less than our 50, less than that initial side we were given, which was also 80. I know that I have two triangles. And the way that I can form these two triangles is one, just like the one that I have drawn, right? So I have this 50 centimeter side drawn. Or I can swing that side in, okay? And instead of having a bigger angle here, I'm going to have a smaller angle here. Okay, so that's going to make this angle obtuse, I believe. Let's look. So my other triangle that I can have might look something like this. Oh, that's too big. Looks something like that. So this was 80 centimeters. I like to draw out all the triangles too. Okay, so that's my other possibility. Okay, and then the last one here is going to be, well, if A, so that was like my 50, is greater than my B, which was my 80 here, then I have one triangle. So this is a really useful tool, I think, and I'm going to show you a way where you don't even need this tool, but I really like to think about it this way. Okay, so now I would have to solve both of these triangles. Really, all I'm trying to do here is find the possible lengths of side Y. So I'm trying to find this Y and this Y. Okay, so in order to do this, so first of all, I know that I have two triangles. And that's because basically my 35, which is my shortest height, my 35 centimeters, was less than my 50 centimeters, which was less than my 80 centimeters. Okay, so always looking for that shortest possible side, and then asking yourself, let me compare these two sides to that, and now I know that I have two triangles. And again, that was this case right here. Okay, so I can now use law of sines to find either an angle or a side that's missing. The problem is that I have this angle on this side, and then I have this side, so I'm probably going to need to find this angle right now, or this angle. So let's see what we get when we use law of sines. Okay, so I'm going to do sine of 26 degrees is to 50 centimeters. The same way that sine of angle Z is to 80 centimeters. Okay, doing the math on that, I get the sine of Z is equal to 0.70139. Now, think about the sine of this angle. Okay, the sine of this angle is 0.7. Okay, so this is a positive sign. Okay, so thinking about where my positive signs are, they're either in this quadrant or in this quadrant. So this is why I have two possible angles here, right? And one of them is going to be my initial angle, and the other one is going to be 180 minus that reference angle. Okay? All right, so when I put this into my calculator, I get the fact that Z is, well, it's an approximate. And I would encourage you to put it into your calculator so that you can double check. And I've got a little bit of rounding going on, okay, which is going to, not give me exact answers, but that's totally fine. So I get Z is approximately 44.5 degrees. Or, because there's two of them, right? The other one's going to be 180 minus this, which is 135.5 degrees. So we have two possible angles for angle Z, which tells us that we have two different triangles. One of them is going to be 44.5 degrees, and the other one is 135.5 degrees. And these are, again, approximations, so they're not exact. Now that I have this other angle, I can then calculate what angle Y is, and if I know angle Y, then I can find the side opposite it. So in this triangle, it's going to be 107 or 109.5, and in this triangle, it's going to be 18.5. Okay, so once again, just recapping, the first thing that I did was I determined the number of triangles. Possible. Okay, and so I knew that there were two triangles. Then the next thing I did was I used the law of sines to find angle Z. But again, I know that there are, when I set this up, I see that I'm taking the sine of Z, sine of some angle, giving me some positive output. And I know that that's possible in two quadrants. Okay, so I found the first angle, which was my reference angle, and then I subtracted that angle from 180, right, which is this reference angle here is really 44.5 as well. Take 180 minus the 44.5, get 135. I now see that I have two possible triangles, two separate angles here, and really I just care about Y, so I'm going to find the angle opposite it by basically adding these up and subtracting from 180. And then you can just go ahead and use law of sines to find Y in both scenarios. So we have sine of 26 over 50 equals sine of 109.5 over Y. And we also have sine of 26 degrees over 50 equals sine of 18.5 degrees over Y. Solving both of these for Y, you're going to get the fact that Y is going to be 107.5 centimeters. And you're also going to get the fact that Y is equal to 36.2, approximately, centimeters. I can put an or here so you can see the two different triangles. Alright, now, how can I do this without having to think too much? Well, if you use the law of cosines and you recognize quadratic formula, or I should say quadratic form, and then put it into the quadratic formula, you can do this without having to think a whole lot. So here's another way of doing this. Okay, so using law of cosines, let's see, I've got this angle and I've got this side across from it. Okay, and what I'm trying to find is this side y. Okay, so I'm going to start actually with using these two things in my law of cosine. So I'm going to start with this side, okay, which means I'll take the cosine of this angle, and then which means I'm going to also use these other two sides in my formula. So I'm going to have 50 squared equals, and we'll do y squared plus 80 squared, right, because it's the sum of the squares of the two other sides, minus 2 times y times 80 times cosine of 26 degrees. Now this becomes really interesting. We can actually turn this into something that looks very familiar to us. So I'm going to keep this as 2500. This is y squared. Now I'm going to take this term, I'm going to actually call that negative 160 cosine 26 degrees y plus, and maybe I'll put that into parentheses so that you can see, plus 80 squared, which is 6400. Okay, now hopefully you can see that this is in quadratic form. So we have y squared, we have something y, we have 6400. I can put this into standard form and I can use the quadratic formula if I would like to. So I'll call this 0 equals y squared minus 160 cosine of 26 degrees y plus, and if I subtract 6400 and 2500, I end up with 3900. So you can see that my A here is 1, my B is the negative 160 cosine 26 degrees, and my C is 3900. And I can plug this into the quadratic formula to figure out what y is. So y is negative b, which turns that into a positive, plus or minus the square root of b squared, which is negative 160 cosine of 26 degrees squared, minus 4 times a times c, all over 2a, or just 2. Putting that all into your calculator, you're going to get two different answers here, and one of them is going to be 107.54, and the other one's going to be 36. Let's call that 27, which matches my other two answers. I rounded a little bit much here, but you can see that that also gives me my exact two answers without having to think too much about it. Okay, so let me just give you a couple more scenarios where we can see where there might be just one triangle or 0 triangles possible. So same angle I'm going to start with is 26 degrees. Same side length of 80 centimeters. And then I'm going to give you that other side of 90 centimeters. Okay, and I'm not even going to draw a full-on triangle here. So to determine how many triangles you had here, you would first try and figure out what's the shortest side I could possibly have. Okay, and so you can see that we have a right triangle here. Call that H. Okay, using sine, right? So I just did sine of 26 is opposite over hypotenuse. We got that your height would be 35 centimeters. Okay, so now going to the handout that I gave you. First of all, the angle I was given was acute. So we're in this column here. Okay. And actually, I don't even care about that height because I can see right away that the side that I was given, this 90 centimeters, is greater than the side that's adjacent to the angle I was given, which was 80 centimeters. So I know that there's one triangle. So I know that 90 centimeters is greater than 80 centimeters, so one triangle. Or I could have used law of cosines. So if I do 90 squared plus y squared plus 80 squared minus 2y 80 cosine 26, and then I turn this into, oops, I messed that up, 90 squared equals, sorry. Turn this into my quadratic form, I'm going to end up with 0 equals y squared minus 160 cosine 26 y minus 1700. And if you plug that into your quadratic formula, you're going to get the fact that y equals 154.79, or your other answer would be 10.98 centimeters. Well, can I have a side length that is negative 10.98? No. So that one's thrown out, and I'm just left with one possibility for my triangle. So using this quadratic formula, getting this into standard form is really easy, or again, you can think about it. Okay, this just kind of gives you your answer, whereas again, this way you kind of have to think about it, and then I could use law of sines to figure out what my missing side is. Okay, now what if I instead was given same angle, same initial side here, but then my other side I was given was 30 centimeters. Okay, once again, my mind goes directly to what's the shortest possible side I can have? That's my perpendicular side. And we found that by using sine, and we knew that it was 35 centimeters. So right away I say to myself, this side right here is too short. It'll never touch this other side. And that's this example here. I say to myself, the angle I'm given is acute. I find this shortest side here. And I know that this shortest side now is actually bigger than this side that I was given, right? So 35 is bigger than the 30 that I was given, so I don't have a triangle. Or using the quadratic form and law of cosines, we can say, all right, I have 30 squared equals y squared plus 80 squared minus 2 times y times 80, a cosine of 26 degrees. Putting that all into standard form. Now I'm going to actually put this one into the quadratic formula just so that you can see. So we get y equals 160 cosine of 26, right? That's just my b, and it's my negative b, so it becomes positive, plus or minus the square root, negative 160 cosine 26 squared, minus 4 times a times c, oops, 5,500, all over 2a. Okay, now doing the math here, you end up with whatever 160 cosine 26 is, plus or minus, and then under the radical, we get negative 1,319. So if you see, my discriminant here is negative. So how many solutions, how many real solutions do I end up with? Right, so remember, this is my discriminant. Which is less than 0. And therefore I have no real solutions. So I do not have a triangle possible.